Hello, I'm Pushkar and I'm Master Teacher in Chemistry at Vedantu and discussing JEE Advanced 2019 Chemistry paper. I am discussing right now paper 2, and in this paper 2 I am discussing a problem from atomic structure. Let us see what is this problem. The ground state energy of hydrogen atom is minus 13.6 electron volt. This information is given. Consider an electronic state of helium plus whose energy, azimuthal quantum number, and magnetic quantum numbers are given minus 3.4, 2, and 0 respectively. Which of the following statements are true for the state psi? It is a 4D state. The nuclear charge experienced by the electron in this state is less than 2 electron, where E is the magnitude of the electronic charge, and it has 3 radial nodes and it has 2 angular nodes. Especially if we talk about the B option, straight away we can see it is wrong because it is helium plus ion. And in helium plus ion, two protons are there inside the nucleus, and there is only single electron. So the single electron is being pulled by these two protons. So effective nuclear charge is equal to 2 electron. So there is no question that the nuclear charge experienced by the electron in this state is less than 2 electron. It is simply equal to 2 electron. So straight away we can say the option B is incorrect. Let us see all other options and how to solve and get the all other options. So first, let us write the expression. We know that En is equals to minus Z square upon N square into 13.6. That's the general expression. And for hydrogen atom, Z is equals to 1. And for hydrogen atom, Z is equals to 1. And the ground state N is equals to 1. So we got this E1 is equals to, for hydrogen atom, that is minus 13.6 electron volt. But in case of helium, this value is 3.4. So we got the first equation that this is equals to minus 3.4. Okay. Now if this is minus 3.4, in case of helium, Z is equals to how much? 2. And upon substituting this value, we get 4 into 13.6 upon 3.4 is equals to n square, and upon solving it gives n is equals to 4. So once we get n is equals to 4, if n is equals to 4, that simply means that it belongs to 1, 2, 3, 4. Let's call it 1, 2, 3, 4, fourth state. And in the fourth state, another very important concept is there, that in one state there will be 2 subshells, in 3 there will be 3, and in 4 there will be 4 subshells. Even if it is H-like species, these subshells will be there, but they are degenerate. As you can see in this diagram, they are degenerate. That means their energies are same. So that's the speciality of a single electron species, that they are in a subshell, in a shell, all the subshells are of same energy. So we have this, and it has been given that L is equals to 2. To definitely L is equals to 2 means what? D state. And so we come to know that this state is what? 4D state. So of course option A is correct. That is 4D state. And in this 4D state, now if we see the question, it has 3 radial node. No question of this because 4D has only one radial node. Use the formula that number of radial nodes is equals to n minus L minus 1, and you can clearly see that is equal to n here is equals to what? 4 minus 2 minus 1 is equals to 1. So radial nodes is equals to 1. And since it is d orbital, it has one angular node. Sorry, it has two angular node. It has two angular nodes because number of angular nodes is given by formula. Number of angular nodes is equals to simply equal to L. Okay. So that is the, if we see this, so our answer is, it is a 4D state, correct. It has a 3 radial node, correct. It has 2 angular node, Of course, it is also correct. So answer is A, C, and D. And if you're interested in what are these two angular nodes, so since if it has been given that m is equals to 0, whenever m is equals to 0, which means that wave function or the quantum state is independent of psi, independent of phi. And if it is independent of phi, that clearly means that it must be z orbital. Okay, why? Because this is the situation that if this is x-axis, this is y-axis, this is z-axis, this angle is theta, and the projection of this is called phi. So being independent of phi means what? The orbital must belong to the z-axis. So if it is belonging to the z-axis, for example, dz square orbital, so that means it is independent of phi. Because you can look at from whatever phi, the value is same. So it must be this orbital, 4dz square orbital, 4dz square orbital. Okay, as you know, and you also know that it has a ring kind of a thing, and it has two angular nodes. In fact, two angular nodes represented like this. They are these surfaces, like a cone. So on these surfaces, as I have shown in this figure, the probability of finding electron is 0, or you can say at these angles, the probability of finding electrons are 0. So it's very interesting problem, and a lot of things are incorporated in this problem. So I hope you understand this. This is the printed solution of this. Go through it and stay tuned for solutions to the other problem. Thanks for watching.